All right, let's try to go through this as quickly as possible. We have three procedures, 1, 2, and 3. The first one is the main, the second one is the input, and the third one is the mul. I'm assuming that you've already looked at the code, tried to familiarize yourself with it, and maybe you're having a hard time understanding what it does. But we're going to go through each and every one of these procedures. So the first one basically loads these two numbers, the multiplicand and the multiplier. So this is saying load 7 into the accumulator. The next instruction, which is the TSX, it says transfer the stack pointer to the X register. That's all it says. Copy the stack pointer to the X register. And then PHA says push the accumulator into the stack. That's all this does. The first three instructions, they just store this value in the accumulator, copy the stack pointer into the X register, and then it says push the accumulator into the stack. All right, so if we look at the next three instructions, we can see it is doing a similar thing. It says load this number, transfer the stack pointer, because the stack pointer is different now, because when we do this push, when we push the accumulator into the stack, it is now pointing to the next memory address, and when we transfer it back again into the X register, now we're transferring the next memory address. And let's actually remember that the stack grows downwards. So let me actually open a new page real quick. All right, so let's remember the fact that the stack grows downwards. So it's like this. That's supposed to be a $sign. So 100, and this is the bottom end, and this is the top end. And if I'm not mistaken, it is FF, right? I think so. I'm not sure, but if I'm not mistaken, that's what it is. So when we push something into the accumulator, it takes up let me change the color. It takes up that address, and now it is pointing to the next one, because when you try to use the next one, you need the available one, right? So it just keeps growing downwards towards the value 100, and that is pretty much how it works. It grows downwards. So I hope that's clear what the main does, at least for the first part of it, the first 6 instructions. And then we go to the jump instructions, JSR, and jump. So these are essentially jump instructions, but there is a slight difference. JSR is going to put the return address into the accumulator, into the stack, not the accumulator, so that when it does the RTS right here, when it does the RTS, it can actually come back. It basically looks at the stack, and it takes that value that was pushed onto the stack, and it pops it, and it goes back to where it came from, which it's going to be right here. It's going to come back to this, so it's going to jump to the mul, right? Let me just clean that up. All right, so pretty much the JSR is simple, and I think that you probably understand it. This is the simplest part of it, and I'm not going to try to explain these, because these other two are the same thing anyway. So now we know that when we jump to the input, we have 7 and 23 in hexadecimal stored in the stack, right? We also have the memory address that we're going to go back to stored in the stack as well. So we can't just do the pop from the stack to store those values into memory addresses, right? Because what we have, let me actually try to draw that quickly. So let's say this is the stack. The very first time we do it, it is the number 7. The second time we do it, we push onto it, it is the number 23. And when we're jumping right here, right, we're jumping to the input, we're actually storing an address that points to the next instruction. Well, actually, technically, it points to itself. It says take the next instruction, which is the JSR mul, and take 1 from it, and store it into the stack. So this is gonna be just some address. I don't know, maybe like 6, 7, 3, 2, whatever. I don't know what the address is. It is just some address to it's an instruction address so that you can jump, that the computer, the program can jump to that. And this is technically, it actually points to this, but when you come back with RTS, it's gonna add 1 to that address. Oops. It's gonna add 1 to this address. It's gonna add 1, and it's gonna jump to that, which is just gonna point to this guy right here. So it's gonna point to the mul. All right, let me just clean that up. And all right, so I hope that's clear what it does. And basically we have, this is the stack, and as we know, it grows downwards. So now we need to, in the input procedure, we need to access these numbers, the hexadecimal 7, and hexadecimal 23. We need to access those so that we can store them in memory addresses, the 800 and the, where's the other one? Oh, 802, right? We have to do that. We have to store those numbers in there. And the way we do that is we say, okay, remember when the last time we pushed the accumulator onto the stack, we also saved the address, the stack pointer, right? We saved it. So when we kind of did the TSX, we were saying, oh, store this address onto the stack, and then we said store this address onto the stack, and now the X actually, points to this address. So if we wanted to get the multiplier, what we would do is we would say load 100 plus X, right? Because it basically the lower bound is 100 and the upper bound is this. I think it's this, I'm not sure, but it doesn't matter the numbers specifically. The logic is what matters. So we're saying add 1 to the 100, add X, and now we're gonna actually point to this number, right? To this value. And so that way we are able to then store it in the memory address 800. And the next time around we do this, so this is actually, I wrote the code just as the professor sent us. This is, I have not made any changes right here so that I can explain what the changes must be. So the next time we need to do, the next one is actually which one? So we did the 23, right? First we do the 23, and then we need to store 7. So the way we need to do that is we need to increase the X. We need to say increase X, and then that will point to 7, right? Once you increase the X with the inks instruction, it will point to the one that is above it, right? Which will be 7. Once we do that, it will point to this. But here the problem is that the professor isn't doing that, and that's the trick. He wanted us to fix that, I'm assuming. At least it works when I do that. So, all right. So let me just go back, and let me fix the thing that I need to fix. So what we need to fix is, instead of saying load 200 into the accumulator, you need to say first increase the x value, right? Increase that. I mean, it's not increase, it's increment. I've been saying it wrong. It means increment, which will just, if it's right here, it's going to increment to the top, right? But above it, right? If it points to this, it's going to increment to the next one in order. So, all right, so that increments it. And the next instruction that we need is not load a 200, but LDA $100 and X. The same thing that is right here, right? Because it just does the same thing, except this time around when we incremented the X with this instruction, we're saying that the X is now pointing to the correct thing. So yeah, I think that's quite simple to understand. And the next few instructions, they basically just set the address 801 to be 0. That is just for multiplication purposes. We just need to initialize it with 0. That's all this does. And then, as we talked about RTS, it'll just add 1 to the value, the address that's stored in the stack. It'll add 1 to that, and it'll jump, which will be the mole. Now, this is the tricky part. This is where it gets hard. Well, it's kind of hard because we don't know a whole lot about 6502, but after reading the there's the 6502.org website, and after reading the instruction set and stuff, it's been way more, it's been clear to understand what it is and what it does. Okay, so let me see if we can make any changes. What I'd like to do, actually, fix the mistakes first before we go on to explain it. So another mistake is that the professor did not stay consistent with the labels. So right here you can see the label is uppercase input, but right here the label is lowercase, and that is wrong. I spent like a few hours trying to see why it doesn't work, and then I realized that there's a mistake with that. Input. All right, now it jumps to the input procedure correctly. The next one, all right, let's see. The next one is here where we increment. I kept saying increase, but it's not necessarily increase, it's increment. So incrementing X, and then we're saying load. Where's the $? 100, and basically just X. All right, that's it. That should fix it now. Increment X, load 100 plus X, store that at memory address 802. Right, so now we know the rest. We know what happens with RTS. Let's jump back to the procedure mul, this procedure right here. So this is going to be a little tricky, but I think we can do it. All right, let me get my white color. Let me just think real quick how I want to go about it. So the very first thing we see is that we're kind of initializing the accumulator with 0 because we're going to use it to do some addition, right? We're going to add to it values that we're going to need. So we're initializing it with 0. Then we're saying load the X with 8 because we have 8 bits in the, well, each number is 8 bits, right? So we're trying to have 8 right there, and it's going to work as a counter so that we can loop through the value 8 times. That is pretty good. All right, so there's the logical shift right, which pretty much just says, let's say you have whatever number it is. Let me actually look it up. For 800, it is going to be 00100011. Okay, so this is the multiplier, I think. And when you do the LSR, when you do this instruction, it basically says do a logical shift to the right, and that'll pretty much just say move all of this thing right here to the right, move all of that to the right, and we're just gonna discard this guy, the 0th bit, but it doesn't actually discard it, it stores it in the carry flag, right? So what the value will be after the logical shift right is 0001000. Hold on, am I making a huge mistake here? I don't know. No, actually, we're good. Yeah. Okay. So that was basically the place that we just got, we kind of pushed into. The value is 0, and the 0th bit has been stored in the carry flag. It just goes into the carry flag. So now we have 00010001. All right, that's what this does. And we haven't jumped to the meat yet. So what we do after that, it says branch to L2 if the carry flag is clear. And in this case, the carry flag is not clear because we just did the LSR, which is the logical shift right, and we kind of put the value that was right there into the carry flag. So the carry flag is actually not clear. It is set. It is 1 instead of 0. So that means that we're not going to jump to L2. We're not going to do that. We're going to keep going with this instruction here, which says clear the carry flag, and then it says add whatever is in the 802 address, which is the multiplicand, says add the multiplicand to the accumulator. Great. And then, as we move forward, this says rotate the accumulator, and the next instruction says rotate the multiplier. Now that is, it's really difficult to grasp why we're even doing that, right? Especially when you don't know what that instruction does. What does rotate really do in 6502? There are a couple of different ways rotate can actually work. There are a few ways that it can be implemented. But the way it works in 6502, and this is actually the reason I was stuck for so long, because I didn't know how it actually worked, what it actually did. So we are going to look at it now. Let me actually go to the next page. Let me write down let's get the multiplicand, let's say. I'm using the same numbers that's in the lab, so like 7 and 23, right? So let's say this is, I'm actually go to the top. Yeah, the accumulator is going to be the 802 value, which is the multiplicand. I don't even know if I'm saying that word correctly. Is that how it is said? It doesn't matter anyway. All right, so 5 zeros and 3 ones. Beautiful. So when we do the ROR instruction, what it says we need to do is we need to shift everything to the right everything to the right. When we do that, this value, the 0th bit, is going to be stored in the carry flag. And the 7th bit, which is this one, is going to be replaced with the value in the accumulator. So that was the missing part for me, because that was really not how I was thinking about it, and I was really confused. But yeah, pretty much that's what the rotate does. And now you might be asking, why are we even doing that, right? Why even do that? What purpose does that serve? All right, so to actually understand why that needs to be done, we gotta go back to the very basics. We gotta try to do the multiplication by hand. All right, let's try to do that. 0, 0, 0, 0, 0, 1, 1, and 1. And the multiplier is 0, 0, 1. Alrighty. So that is the multiplier. And we're multiplying both of these numbers. And we remember from, from school how to do this, right? We're multiplying we were multiplying this value to the multiplicand, and we're putting it down here. That's going to be, basically we're just going to copy it here, 0, 0, 0, 0, 1, 1, and 1, right? All right, next up, we're going to do this one. I'm just going to go through this very quickly because I know that everyone in this class already knows how this is done. Next up, it's just a bunch of zeros, and we know that we're not going to put when you do this, you're not going to put it right here, right? You're not going to start writing from there. You're going to start it right here. We're going to write it below the number in the multiplier that you were using to do the multiplication. So keep that in mind because that's going to be very important when we get to the next part. Okay, so there's another one of that. I know this is really boring to watch me type, write zeros, but I feel like it's going to be really good for you to see what is even happening. 1, 1, 1, 0, whole bunch of zeros. All right, and then some more zeros. And one more set of zeros. Okay, now we're ready to add them up, right? We are ready to add these. So how we do it is we're gonna move this guy down there, right? It's gonna be 1. It's gonna be 0 because 1 plus 1 is gonna be 0, and then we're gonna carry that 1 to here, and then we're gonna say 1 plus 1 is 0, but then we have also another 1, so it's gonna be 1 down there. Actually squeeze it in a little. Okay, 1. No, that was good. That was fine. So 1 there, but we are going to carry another 1 over here because these two added and turned into 0. So we carried the 1. And all right, let's continue. There is a 0 because those add. The 1 is being carried over. All right, and we're going to get these 2 down. And now we have how many bits? That is 8 bits, and we don't care about the zeros, so we're just not going to write them down. So this is the value that we just got. This is the result. And this is what you will get when you do the multiplication in the program. So we gotta pay attention to what happened there, right? What we did, we looped through the, we're looping through essentially the multiplier, and from the right hand side, from here, we're saying, okay, we have a 1, that means we need to add the multiplicand to the accumulator. All right, cool. We also have another 1, we're gonna add it to the multiplicand, we're gonna add the multiplicand to the accumulator again. And for zeros, we don't do that, we're just adding zeros. Basically, we're not adding anything. And then we have another 1 in the multiplier, so we're gonna add the multiplicand to the accumulator one more time. Great. So pretty much what it does, and the way we in the program, the way it does, it goes into a loop, and that's why we stored 8 in the X register, so that we can go through the loop 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. We go through the loop 8 times, and whenever we see 1, we add the accumulator onto the, we add the multiplicand to the accumulator. This is the multiplicand to the accumulator. And that is very, that's understandable, right? That part is easy to understand, why we're rotating the multiplier, because when we rotate it, we move everything to the right, and we can actually look at this now. When we rotate it, actually, we're putting the 0th bit into the carry flag, and when we look at the code, we can see, once we jump back to this, we can see it says branch of carry is clear, but the carry is not clear, so we're going to add the multiplicand to the accumulator. Easy, right? That makes total sense. But what doesn't make a whole lot of sense, when you see that the accumulator is also being rotated right. Do you see this code? This piece of code literally just rotates the accumulator. And when I say rotate, we know what it means, right? It means to move the 0th, move everything to the right, and move whatever was in the 0th bit into the carry flag, and whatever was previously in the carry flag, move that to the 7th bit, essentially the top bit, right? The leftmost bit. All right. Now, why? You might ask. And I'm going to try my best to explain it. Do you remember the comment that the professor posted at the top of the code? Let me try to copy it to the tablet. Let me actually... Ooh, it's taking forever. Beautiful. Okay, let me actually try to make it white so that you can see it. Beautiful. Beautiful. All right, we can see it now. So what it says is that 800 stores the 800 and 802 both store the numbers that need to be multiplied, but also in the output it says that 800 is also the low byte of the product. And we know that it's little endian, right? At first we store because the thing is that we're multiplying two 8-bit numbers. We can't store that information in just 8 bits, so we might go over. That's why we need to use 16 bits to store the value. And we're using little endian, what is it called? I don't know. Basically, little endian technology to store them. So the very first address is 800. That's the low byte of the product. And then the next one is going to be 801. And that is going to be the high byte of the product, right? So, but we also see that we're using 800 for two different things at the same time, and that is what's really confusing. 800 is used for the multiplier and for both the low byte of the product. But why and how even, right? That is where we can look at the code and try to explain ourselves. So, let me see if I can explain it correctly. Okay, yes. So, when you see these two rotate instructions, let me get a different color because that doesn't. Alright, so when you see these two rotate functions, what they're essentially doing is they're going to, the first one is going to say rotate the accumulator, store whatever is in the 0th bit into the carry flag, and then the next rotate, which is the rotating the multiplier, it's going to say take whatever is in the carry flag, put it as the 7th, the 7th, what is it called? Bit of the multiplier after you shift it, of course, and you also put the 0th bit into the carry flag. So that is really confusing, and that is not the best way to explain it, but I'm going to try to go through it here as well. So when we do the multiplication, as we know, we're using the, let me get a completely different color. So this is the address 800, right? This is used for both the multiplier and for the low byte of the product. The way it does, the way it does that is it says, all right, this is whatever's in the accumulator. Now, the next time around we loop through the thing, we're not going to add the multiplicand directly to the same value, right? It would be basically doing this. It would basically say, okay, I'm just going to add, oops, I made a mistake. It would just basically put them on top of each other directly, and it would add them. That is wrong, because we know by hand multiplication, we don't do that. We move it one number to the left, right? So that's what it does, and it kind of says, pay attention just to the part that you need to pay attention to, which is just this, right? It says add to this part, right? These two parts, just add them together. That's what you need to do. And then what it does, it says take this number, which is in the accumulator, take this bit and put it into the carry flag, and then after that, when you do the rotation to the 800, which is the multiplier address, when you do the rotation to the multiplier, you're gonna take the carry flag and we're gonna put it there. Well, not necessarily there, because what you're gonna do is you're gonna say take this whole thing, move it there. Now, put the number in there from the carry flag, and you also kind of discard this guy, but you don't discard it. You take that and you put it in the carry flag, right? So in that way, as you go through the loop 8 times, you're gonna kind of get rid of all of these values, and you're gonna keep adding the low byte of the product into the multiplier address. So you're kind of getting, shooting each bit one by one and replacing them from the leftmost area. You're replacing them with the actual result, with the low byte of the product. And here we can see that the accumulator is just going to keep adding the necessary stuff. We don't really need this one to stay in the accumulator, because it really is not affecting the rest of whatever is happening here, right? That one is not going to affect anything. So as you keep doing that, as you keep adding them, you end up with 0. So the high bit is 0. That's what you can see when you actually run the program in the emulator. The accumulator ends up being just 0, which is actually then stored in the memory location 801. If we look at this right here, we can see we are storing the accumulator in 801, and it is 0, because after many additions, you just end up with 0 in the accumulator, but the values that we needed, which are all these little guys, they're all moved into the multiplier one by one with every rotation. That was not the best explanation, and I don't think it was very clear for anyone, but I did my best. I understand it, but I might not be the best at explaining it, especially because I'm trying to keep this short, and this is probably already not short. So I'm just going to pause this, and hopefully you guys understand it, and hopefully if you really want to understand it, this might kind of put you on the right path. If it doesn't explain it, like if it doesn't actually make you like go, wow, I understand it now, it might actually just put you on the right track to figure it out on your own. All right, I'm gonna send it.